Okay, so we have a ball with a weight of 5 newtons. Now look, that's not mass. That's the weight of the ball. If you want the mass of the ball, how would you find the mass of this ball? Yeah, you use the definition for weight, right? W equals mg. So the mass of the ball, you're going to go W over G, 5 newtons. For these AP questions, you use 10 for gravity, right? So this simplifies to 0.5 kilograms. The mass of that ball is 0.5 kilograms. Okay, the first question, so the ball weight suspended by 2 strings. So first thing they want is a free body diagram for the ball showing all the forces and any angle. So is this ball moving yet or just hanging there? It's just hanging there. When we get down to part 3, the ball is going to be in motion. But for questions 1 and 2, the ball's just hanging there. Okay, so let's do our free body diagram. So here, this dot right here represents the ball. So how many forces are on the ball? 3. You've got mg down, which is equal to 5 newtons. We have tension 2 going this way, and then we have tension 1 going this way. This is not to scale. Here, let me fix this. So T2, this is at a smaller angle. So we'll go T2. That looks a little better. T1. Now show the angles. This angle in here, if that's 37, then that means that this is 37. If that's 53, then that means that this is 53. All right, now what are we going to have to do to T1 and T2? Hopefully I've trained you well to break it apart. Right away, you recognize that T1 and T2 are not perfectly X and not perfectly Y, so they are going to have to be broken into components. You know, like, so T2 has an X component and a Y component. T1 has an X component and a Y component. Okay. Number 2. Oh, and by the way, don't show components. See these red arrows that I have here? On the AP test and the midterm exam, don't show me the components. You know, you would just want to show the 3 black vectors. Those are the forces. You don't need to draw in the components. I do it. I put it in a different color just so it's more clear, but it'd be better to not show it on the AP test. Yeah, in fact it says right here, and angles. So show angles. Okay, question 2. Determine T1 and T2. So guys, how are we going to find T1 and T2? What do you do after a free body diagram? You sum the forces. So here we go. Shh. Shh. Summing forces X. We have 2 X forces. So we have this guy, the X component of T2, and we have this guy, the X component of T1. So here's what this will look like. We're going to say cosine 37 T2, that's this guy, that's cosine 37 T2, minus cosine 53 T1. Okay, those are the only 2 X forces. Sum of the forces always equals ma, but is there an acceleration this way? No, the ball's just hanging there. So this is going to be equal to 0. Okay, so we just wrote a very helpful equation. All right, now we go to the y direction. In the y direction, we have 3 forces. We have the y component of T2 pointing up. We have the y component of T1 pointing up. And then we have mg pointing down. Okay, and by the way, mg is equal to 5 newtons. Okay, so in the y direction, we're going to go. So start with let's start with T1 over here. So we have sine 53 T1 plus sine 37 T2 minus the 5 newtons. Mg is 5 newtons. That's the sum of the forces. what does the sum of the forces equal? ma, but is there any acceleration this way? No. So the a is 0. Let's put in 0. Okay, so at this point, guys, it's algebra. What you have to do is substitute these equations together. So like take this x equation here. Let's solve it. So t1 is equal to, that's going to be cosine 37 t2 divided by cosine 53. Oops, I can't write today. 53. What I would do here, I mean, usually I tell you don't plug numbers in till the end, but I think it'd be really helpful to simplify this. Just figure out what that ratio is. So this is going to give you something t2. So take that, plug it in down here. No, I'm sorry, not there. Plug it in, t1 equals something t2, plug it in right there, and then you're going to take this equation, solve it for t2. You know what I'm saying? You guys can do the algebra. You have two equations, two unknowns. If you do the algebra correctly, t2 will come out as 3 newtons. Wait, what am I doing here? t2 will be 3 newtons, and t1 will be 4 newtons. Okay? So that's 1 and 2. Now, the next part of the question. Suppose that the ball swings as a pendulum perpendicular to the plane of the page. So what does that mean? It means when the ball's right here, what's the ball doing? It's coming straight out of the paper into your face, right? The ball is coming straight at you, right? It's swinging like a pendulum attached to these 2 ropes, okay? And achieving a maximum speed of 0.6 meters per second. Guys, where's the maximum speed going to be? Is it going to be at the highest point or the lowest point? At the lowest point. Okay, so we have the velocity of the ball there. Now look, where is the center? This ball, if it's swinging as a pendulum, it's in a circular path. Where's the center of the circle for that circular motion? The center of the circle is it going to be over here? No. Is it going to be over here? No. The center of the circular path is going to be straight up. Bam, right there. This dot, that represents the center of the circular path. And by the way, what's the radius of the circle going to be? It's going to be this distance right here, this dotted line, dot, 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 dot. That's the radius of the circular path. Can we solve for that radius? Yeah. You could either find the radius by using this triangle or by using this triangle. Either one will give you the radius. Okay, so let's do this. Let's find the radius. But first, let me make some room here. All right, so finding r. Let's use the left triangle. So what are we going to use? Sine, cosine, or tangent? We got opposite and hypotenuse. What's that? So you go sine of 53. So opposite is the radius. The hypotenuse is 0.51. So that radius is going to be sine 53 times 0.15 meters. So the radius of the circular path comes out as 0.12. Okay? And we know that the velocity at that lowest point is equal to 0.6 meters per second as it passes through the lowest point. The question is, so number 3, determine the magnitude and direction of the net force on the ball as it swings through the lowest point in its motion. The net force. Okay, guys, what is net force always equal to? It's equal to ma. What type of A is this? It's centripetal because it's in a circular path. It's a centripetal acceleration. So what must the net force be? The net force, if that's a centripetal acceleration, the net force must be a what? Centripetal force, right? Centripetal acceleration always points where? To the center of the circle. So we can solve this pretty easily. We're like, okay, the net force is a centripetal force because it has a centripetal acceleration. This is going to be equal to m. Now look, is there an equation for centripetal acceleration? Yeah, v squared over r. So the answer to the question is going to be mv squared over r. So F net. So the mass of the ball is, oh, here we need the mass. I solve for what is the mass? 0.5. 0.5 kilograms. We did that at the beginning. The velocity was given, 0.6. And then you have to solve for the radius. So this gives a net force of 1.5. Directed which way? To center of circular path. Now look, what else is the net force? There's another way we could have looked at the net force, although it wouldn't have been solvable this way because we don't have enough information. But the net force would be this guy plus this guy minus that guy, right? If you sum the forces in the y direction, which we already did, we have sine 53 t1 plus sine 37 t2. I got to erase this. Minus 5 newtons, right? We sum the forces in the y. What is this equal to? ma. But it's a centripetal. So look, this is exactly what we did. So look, that right there is the net force. But notice what it's equal to. It's equal to MAC, which is what we did right here. That's what we did right there. You know, AC is equal to V squared over R. Plug it in. Bam.